I would like us to remember that we don't just have to rue the damage, although that's happening too, but really just constantly create this drumbeat toward this fantastic future of abundance that's right on the verge of it.
We now understand the technical well enough to realize the material equivalence, or even remember, if you will, our kind of human collective history where we were building with biogenic material.
Hello, and welcome to the Reimagine Edit, a special series of the Passive House podcast that shares curated insights from our experts in residence at the Reimagine Buildings Collective, our membership community that brings together building professionals ready to tackle climate change so that we can create the healthiest, most sustainable buildings, deliver them cost effectively, and thrive in the process. Today is April 18th, 2025. And in this episode, we'll hear selected clips from lots of amazing folks, including Carmel Pratt from her Ask Me Anything session, Irwin and Silas Patlove from their Duck Curve Friday session about buildings in the grid, 7 members of the collective who share their choice recap nuggets from the BuildingEnergy Boston conference, Ilka Cassidy from her Ask Me Anything, Lloyd from his Sufficiency First Ask Me Anything, and Andrew Peel from his Passive House Modeling Ask Me Anything. Lots of stuff. It wasn't easy, but I chose the best of the best from each of these sessions for your listening pleasure, and I think you'll enjoy it. I'm Zack, Director of Passive House Accelerator and host of the Reimagine Buildings Collective, and a big thank you to you for tuning in. All right, we're going to keep this fast-paced. So let's start with our expert in residence, Carmel Pratt, who's Vice President of New Construction at Bright Power in New York City, as well as the co-host of the Next Up series of our Passive House Accelerator Live, and a host of the Reimagine Buildings video series, Massive Passive. At her Ask Me Anything session on the collective, we focused on massive passive or big passive house buildings. And I have a couple of resilience-focused clips to share with you today. This first one shares a quick and dirty way to future-proof buildings for rising temperatures.
An approach we take to our recommendations at early design, especially for large buildings, because of internal heat gains there, they tend to be cooling dominated regardless of the climate they're in. And so we are always pressing. When we approach a project at design, we like to have a little bit of a buffer. If the PHI or FIAS target heating or cooling load is 4.7 or 3.5 or whatever it is, we say, okay, great, that's the target. Now give us a 10% buffer going into design. For buildings that are tight against both heating and cooling loads, we prioritize the peak load and creating more of a buffer there. Even if we're giving up a little bit, we're performing a little worse on the heating side, we know that that peak cooling event is going to be more problematic to the building long term. So that's a very quick and dirty, you don't need to do any research projects, but just like a practical approach to design and to thinking about a building's extreme event is looking at that peak cooling load and designing even lower than what the PHI or FIAS programs are telling you are like the target limits.
Carmel then addressed how to protect affordable housing buildings from wildfire smoke.
We're seeing fires pop up a few miles outside the city, as close to as in the city. Prospect Park, I don't know if people know this, but a few months ago, there was a wildfire that caught with strong winds that caught in the middle of Prospect Park in Brooklyn. So these things are happening that are triggering us to think about ventilation and indoor air quality in a way that we haven't before. And that's nicely baked into Passive House. Affordable housing is receiving higher subsidies for pursuing Passive House. And that's one incentive to go the extra mile of doing Passive House, which requires balanced filtered ventilation and therefore improved indoor air quality. That's a benefit above, like I said, and I mean no judgment because we love Energy Star and LEED, but it's a step above the lower grade energy standards. And the benefit there, and I'll say there's a couple of things to consider with ventilation. Is it a central system? Is it a unitized system? Each have its pros and cons, especially during a fire event. For example, a central system is able to be either shut down or operated in a boost mode or accessed generally for operation a bit easier and a bit quicker in terms of building facility maintenance staff getting to it and knowing what to do, versus if you have unitized systems, you're relying on tenants to respond and operate and maintain something a little quicker. So there's pros and cons to that, like central versus unitized. And then of course, there's the consideration of the level of filtration that you're adding to the system, right? We always say MERV 8 as a minimum is a good starting point. MERV 13 is, I think, where the industry's found a sweet spot between not having to overburden and overcompensate the actual motors of a fan to overcome that level of filtration, but still filter out a good level of particulate matter. So ensuring that you have a good high 8 to 13 range MERV filter on your ventilation system. And then understanding from like a operations perspective, what to do in a fire event. You actually want to shut down the building so that you're letting in as least amount of air through uncontrolled sources and leakage. And really you want any air that's coming into the building during that time to be going through your ventilation system, your energy recovery ventilator, ideally, if you're in a passive house, so that it's running through that filter.
Next, we pivot to a couple of highlights from our special Duck Curve Friday Ask Me Anything with Reimagine Buildings Collective members Graham Irwin and Silas Patlove. The duck curve refers to the shape of the graph that delineates the daily mismatch between building energy consumption and solar energy generation. We'll start with Graham Irwin, owner of Essential Habitat Architecture in California.
I believe this is the original duck curve, or one early on, and Silas already well described it. Most of the focus is on the belly due to solar. The head, as he mentioned, is due to evening energy use, which is the time of peak load on the grid. And that's a really expensive and challenging time for the grid. So how expensive is it? Just as a rough local to us, at least, sense, in California, the code measures energy in TDV, or time dependent valuation. And it's like an energy unit that is mostly tied to cost to deliver. And so all that is, this is like a yearly plot of the multipliers to convert like a kilowatt hour of regular energy into this time dependent value. And the main thing I'm showing is that between peak and baseline, it's like a factor of 26. So supplying power at peak is roughly 20, let's say 20 times more expensive than at baseline. So a really big issue economically. And another study I found suggested that a 5% reduction in US peak load, not US total electrical use, just the peak load, 5% reduction is worth about $3 billion a year. And this pie chart is showing where those savings come from. And when I first found this, I thought it was quite interesting. You know, about 80% of that savings is in equipment that has to sit there most of the time waiting for these peak events. The energy savings are only 10% So it's mostly that you have these frequent but isolated hourly huge demands on the grid. And so to avoid brownouts and stuff, you've got to have equipment that's sitting around doing nothing. And the capital cost of that is enormous. So what's tau? That's the thermal time constant of a building. And technically, one definition of it is it's the time to reach 63.2% of the temperature difference between indoors and out. So if in the wintertime you turn your heat off, however long it takes to get 63% of the way to outdoor temperature in your house is tau. Passive houses have very long thermal time constants on the order of 200 plus hours. So what significance is that to us? So you have a building with a low or a small time constant, meaning an inefficient building. So people are coming home on hot days and they turn their air conditioning on all at the same time. because they have no choice because all their houses are hot. As you get up, these graphs are showing buildings with longer and longer time constants. As you get a longer and longer time constant, the temperature tends to swing less inside the building, and it's shifted away from the peaks outside. The gist of this is this would be with no space conditioning. The passive house doesn't know what time of the day it is in terms of peak temperature. It essentially averages the whole thing out. And so what that means is you can choose to run your space conditioning when it's convenient rather than when everyone else has to do it. And so that's this value of this tau. I mean, it has a lot of benefits for individual homeowners and occupants of these buildings, but I think it's also potentially a huge benefit value economically and to the grid in general. So the passive house can perform as a thermal battery itself. Again, it won't run your lights or your dishwasher, but it can store that temperature for a very long period, allowing you to run the conditioning when you want to rather than when you need to, Silas. So that was sort of what you were talking about with your apartment building, right? Imagine if you could run that heat pump anytime you wanted and you didn't have to overheat it to keep that comfort level up.
And here's Silas describing how he decided to tackle the duck curve in his own apartment.
Until recently, that big ramp in the afternoon as solar's ramping down and demand is ramping up has been met by natural gas peaker plants. But in the last 5 years or so, batteries have enormously expanded. So from 2021 of almost nothing, we have now almost something like 5 or 6 gigawatts available of battery storage on the grid. So batteries discharging in the morning to help meet that morning peak, charging during the day, and then discharging again to meet that big afternoon demand peak. So my thoughts about this were even before these expansion in batteries, are what, if anything, can be done on a building level to try to avoid the need for batteries as well as avoid the need for gas peaker plants by bringing load into the middle of the day.
Silas went on to show how he MacGyvered his hot water heater and his heat pump to run more during the day and less during the night, better matching the energy draw of both with daytime solar energy generation. He was able to move over 50% of evening energy consumption to daytime, and that was in his non-passive house apartment. The results would have been even better with the long tau, or thermal time constant, of passive house that Graham was describing. Lloyd Alter, the prolific writer, sustainability thinker, and educator, and expert in residence of the collective, had this to add about the idea of buildings as thermal batteries.
This is such an important issue. I mean, there have been 2 studies. One study, when you look at the country as a whole, the issues of how much electricity that we will need is insane. One study said meeting the peak with renewables for the winter peaking would require a 28 times increase in January wind generation or a 303 times increase in January solar. But a highly efficient building electrification can shrink this significantly by a factor of 10, so where we'd only need 36 times more solar. And the point is that this is why all of these people who say fabric first now doesn't matter anymore, now that we have heat pumps and we have clean electricity, the problem is how much clean electricity we need to shave those peaks. And this is where passive house comes in, turning our buildings into thermal batteries. The issues are, even Wolfgang Feist did a study that said the power requirement is reduced by 50% during peak heating times, and the temperatures fall less quickly to less low level with possible lowering heating output. So in Europe, they're actually now talking about computer connections of heat pumps in passive buildings and water heaters in passive buildings to the central electricity supplier, so that since the house is a thermal battery, they can actually turn them both off at points of peak demand, even if it's a point for minutes or 10 minutes or 15 minutes, which is often what these peaks are. The idea is that if we've got passive buildings and we can control the heat pumps and the water heaters, then we can dramatically reduce the need for equipment, for gas-fired backups, for any kind of storage, because the buildings themselves provide the storage. So this is a huge opportunity.
Now let's move to experts from the very cool Reimagine Buildings Collective member-led recap session, sharing key takeaways from the recent NESI Building Energy Boston conference. Sara Kudra, founder of Architecture Towards Neutral, kicked it off with help from Jacob Jurkusen of New Frameworks and also the instructor of our Managing Embodied Carbon mini course in the collective. Jacob co-organized the conference. Let's start with Sara.
This was a collective brainchild of a lot of folks on the call today who attended NESI, and then we were like, hey, we have some fun things we learned, and like just kind of in the nature of the collective to do the share back. So I'm actually gonna put Jacob on the spot because this year, Jacob and his co-chair, Kirsten, thank you, Kirsten, ran the event. So can you give a super high level of the theme and like just what this conference is for anyone who doesn't know?
Yeah, absolutely. So if you've not yet discovered NESI, Northeast Sustainable Energy Association, it's a phenomenal organization that's kind of unique as a nonprofit. I'm not sure if it's completely unique, but particular in that they really serve as a networking organization. So they're not conducting research, they're not building things that's really focused on community development and networking and sort of empowering a multi-stakeholder group of community members in the Northeastern United States and Eastern Canada. So fabulous organization and the perfect organization to hold a conference on the theme of building the movement, which was the theme for this year, which has a couple of different interpretations of what that meant. Certainly the need to move out of our individual silos as practitioners or policymakers or stakeholders, if we're trying to achieve these really system level goals of energy transition and decarbonization in the sector, we can't do that just within our individual practice or even within our individual field. It really requires a coordinated effort across multiple different parties and organizations and stakeholders to make that level of transition. So that type of movement building was certainly one level of the theme. The broader theme is actually even looking at on an organizational level and looking beyond not just what it means to do that work with our professional hats on, but as passionate individuals and as mission-driven organizations, how to find each other and work together in the face of really, really intense challenges and headwinds that we're seeing acutely right now with a lot of the economic and political shifts in the United States, but just in general, as we get further into the energy transition, we're hitting into some of the harder to solve problems. And so it really takes to be able to empower ourselves to do this work. It's incredibly difficult to do that alone. And the sort of entrapment of isolation is a really major barrier to making really substantial change. And so part of building the movement is just to be able to get solidarity and support and mutual aid in the really challenging work that we're all facing right now.
Next, we hear from Bev Craig of Mass CEC and the co-host of the Project Showcase series of Passive House Accelerator Live.
Concrete, green concrete, and how we decarbonize concrete. I learned a couple of things. Like, I just don't think you have the conversations without having a really quality panel talking and then a deep Q&A to learn some of this kind of stuff. But I learned in Massachusetts. So there was a project, a big office building that Turner did. They were aiming for 25% below the regional benchmark for concrete and greenhouse gas, and they were able to get to 49%. No increase in cost, right? And they only use fly ash and slag. And so this is like a big warning light for me. I'm on a committee for procurement for the state on Buy Clean. And if they can do that at such low cost, first of all, like the targets people were thinking of are way not ambitious enough to start and like to ratchet down. And then also just sort of in discussions after that session, I realized we have to do something to do even like a small percentage of alternative like binders, because you can go really deep just using the traditional stuff people have always done. And all we'll do is buy the world's fly ash and slag. And so we have to do something that's a different approach than that.
Next, collective member Rainger Pinney shares more about progress in green concrete.
I actually, another related conference, the New York Green Build that happened the following week, there was a really cool on this same subject presentation that was like someone from New York State, someone from the MTA, and a representative from AECOM, just like a massive global construction company. And the AECOM guy was saying that they, because of their purchasing power, they've been able to get concrete suppliers to essentially compete for who can have the greenest concrete for their project and with zero cost premiums. And that's just like an example of where the purchasing power really comes in. And the folks from the state were saying that half of all concrete in the US is bought by government entities. So, I know right now the governments are trying to start attainable, so they're not like putting anybody out of business. But as they start ratcheting up those goals, it's really clear that the folks with more purchasing power can really just drag the industry along.
And Sara emphasizes the buying power that architects and firms have for things like green concrete.
I was able to attend the Design for Freedom conference last week, and a couple of data points were being shared, but one is about that buying power. And like you're saying, AECOM is enormous. Architects and firms at that scale have something to the order of magnitude 150% of the buying power of your average consumer. The average consumer is 1%. And that architects, what they choose to specify has a ripple effect. It's incredibly imperative that we are aware of all these layers involved. And that conference really brought in the human aspect of this, the embodied forced labor, we're starting to say, because a lot of the market is subsidized by unpaid and forced labor in modern day slavery situations. And we need to include that in the conversation. It's not only about embodied carbon. It's not only about circularity. Those two things also take into consideration how you better the industry to make a better and more human-centric world overall. And then you guys have your comment real quick about the fly ashes. And then the problem is that's the byproduct of coal, right? So now we're starting to create demand for this dirty byproduct industry that it used to be trash. And so it's good we're making use, but to really start thinking about those things and shifting away from that, there's companies now that are even starting to create circular economy around concrete, reusing concrete, regrinding it, and using that as a supplement, like the existing material to add back in.
Kristof Irwin of Positive Energy emphasizes the human element of all of this.
I just want to draw the analogy to, we've learned how, over the last 15 years, how to arrange building materials to get outcomes, right? We've had to think very carefully on the interfaces, the details, the connections. And it really feels like the next phase of our industry is arranging our groups, our connections. How do we arrange these elements to get the outcomes we want? And fundamentally, we humans here, we are head and shoulders the highest embodied material we ever interact with. Every building, every bit of food, it all comes here. But what happens here, here, and here are so important, and they're so underestimated, right? And just to be a tiny bit dark, we know that if you weaponize information flow, it can go one direction, but we can also take it the other way. And I really believe humans are drawn to a future that they long for. It's like this implicit drive. So I would like us to remember that we don't just have to rue the damage, although that's happening too, but really just constantly create this drumbeat toward this fantastic future of abundance. That's right on the verge of it.
Thank you. Well, and I think that's a really important and meaningful moment. And I agree with you. And a little bit of my reflection is also that we're sort of at this moment bridging the technical know-how that sort of high performance land that was so petroleum heavy, right? All the foams that would require, we felt, to really achieve what we needed. And we're starting to be able to disassemble that. We now understand the technical well enough to realize the material equivalence, or even remember, if you will, our kind of human collective history where we were building with biogenic material. But I think that human connection is a really powerful element to this.
Next, Alexander Gard-Murray, the new executive director of Passive House Massachusetts, shares his learnings.
I think in terms of particular takeaways, I think I was really excited by all the mass timber stuff I saw, and I really enjoyed some of the mass timber panels that I was lucky to get to. and just seeing the kind of exciting, ambitious uses were really great and really encouraging. And on the passive house side in particular, I have long lists of notes, but I think it was really one of the key things was summed up well by a presentation from Michael Brown, where he's talking about the top 10 reasons for project failure. And number one, I think, was like thermal bridging or something, but 2 through 10 were ventilation. There's the word ventilation over and over again. And I definitely heard that a lot. I think to Sarah's point, we have a lot of the technical know-how that we need to solve a lot of problems, but I think there are still things that kind of need our focused attention, even in something like passive house, where a lot of the understanding is very advanced. I think there are still problems that we need the community to come together and address. And that was a message I got loud and clear. So that was an important takeaway for me.
And Sara highlights why Andrew Heims's keynote message was so powerful.
I really enjoyed the keynotes, right? So Andrew Heims of the Carbon Leadership Forum spoke on the first day and reflected and shared some content about what a spiritual warrior is, and that we all are kind of going about this work and engaged in this work because of the love we have, the love for one another, for our families, for our communities by extension, and for the world we live in, right? And that we want to preserve that and allow that to be passed on and continue on. And so that reflection that we're really, it's starting to again pull in the whole self. It isn't as a siloed approach, right? And that was another one of the keynote topics, was breaking down those silos and how to incorporate this work in a way that kind of feels meaningful and personally sustaining. I think there were a lot of stories about that, about how people were feeling, are feeling. Let me say, that's really what came up, is this moment we're living in politically right now in the States is pulling back a lot of the kind of uncertainty and fear folks felt when we went 5 years ago into lockdown for the pandemic. And there were a lot of parallels being pointed out in the sessions that I was attending about how the people doing this work are also now really also focused on caring for themselves and their people and their community, to be more conscientious of that. We have some of the similar parallels where certain folks are being targeted and they have to recede and hide and be on lockdown in a sense. And so we need to kind of show up and speak up on behalf of people who are being diminished right now. If you have the capacity to be out and to be mobile in this very tumultuous landscape, but to be using your voice in a really meaningful and powerful way.
Now let's pivot to the Passive House Panelization AMA with expert in residence Ilka Cassidy. Ilka is co-owner of Holstrom System, as well as co-host of the Passive House podcast and co-host of the Construction Tech series of Passive House Accelerator Live. In this first clip, she discusses scaling up DFMA, or Design for Manufacture and Assembly.
What I would like to see happening is, being able to scale this, because we're one little company that is trying to figure this out on project by project basis, but to really streamline panelization or prefab into workflows of architecture, offices, and contractors, and everyone becoming more and more comfortable with it and happier with results and outcomes. I think on a broader scale, this streamlining has to happen. This kind of communication piece, that connection has to be better. And I've actually been talking a lot about DFMA, which now is becoming a more recognized term, where it was developed in the 80s as a reaction to isolation within automotive factories, where everyone was doing their part, but not really thinking about the whole. And so DFMA is actually trying to have a holistic view and not just have engineers on one side and then people that are putting pieces together on the other side and not communicating. It's because that in order to make it work, this all has to go together better. But what's interesting is that now DFMA is being used in the building sector too for prefab, but it's not really integrated. So it's still fairly siloed to the manufacturer piece and not necessarily to the engineering and the designer. So I think for me, our goal is really to just broaden that understanding a little bit and really working on true DFMA.
And Rainger Pinney points out the potential for the mass timber movement to drive adoption of DFMA.
I really think that the mass timber industry taking off is going to really help to drive the DFMA into mainstream, because the design for manufacturing, one of the really big aspects of that as it relates to mass timber is optimizing your design around the sizes of the products that each manufacturer makes so that there's less waste. And so you have better yield, which can help with cost, and then also designing around certain grid spacings to optimize. And it can make or break whether a project pencils out with mass timber if you are designing around those constraints from the beginning. And so there's a real emphasis on bringing the designers into collaboration with the manufacturers at the very beginning. And I think that will have an effect of normalizing the design for manufacturing and help to illustrate how much cost and efficiency savings there can be if you're really optimizing your designs for the way factories work. And that's something that I really relate to, coming from a woodworking background, where I'm thinking about panel sizes and lumber size, like availability sizes, while I'm designing to optimize.
What's also really exciting about the mass timber and it taking off too is something that we've been thinking about as well, is the circular economy, reusing and deconstruction, because mass timber is perfect for that, right? You have these, and especially if you optimize the sizes and use as big as possible, then the chances of being able to reuse it is really high. And then it goes back into the engineering. How do you develop all these connections so that you can take them easily apart? And then it goes into, okay, how do you layer outside of that mass timber envelope, however, you use it, kind of informs what your next decisions are. Again, it's this kind of way of rethinking, like a little bit of this paradigm shift, where it's okay, if that is my priority, if that becomes, for example, deconstruction with mass timber, then you can't really use spray on liquid applied products, right? Then you might want to use like a membrane or have different connections that are airtight, even just between the mass timber. So it's really interesting and very exciting, I think, like all these possibilities. I think I'm always just amazed, Shannon, going back to what you said in the beginning, just developing these things, just seeing the possibilities of new things coming up and not just taking it as what it is, but also thinking about, okay, what else can it do?
Here, collective member Greg Leskien shares his observation about vertical integration in prefab.
Over the past couple of years, I've been kind of going to all sorts of different conferences or attending online. And the one interesting trend I noticed in the US was that the companies that were brave enough to claim cost savings as a result of prefabrication were the ones that seemed to be integrated vertically with other companies, meaning that a group had come together to use one product. So you'd have an architect, someone who was designing for manufacturing, contractors to install them, panelization plants, and they weren't one company. They were a group that came together and stuck together and did projects more than once. And those were the ones in the presentations, and those are the ones I talked to that were saying, like, in addition to saving time on site, we could also save you cost. Whereas when I would speak to other manufacturers that were just doing like a panel, for example, it would be like, we can promise cost certainty and time savings on site, but we can't promise cost savings. So I think that observation you did there, Rainger, was a pretty key one, right? Like, we need to do this repeatedly, and you need to have a team that repeats it, working with a common product to truly see the benefits that were being described here today, like through the whole line.
And speaking of prefab, Expert in residence Andrew Peel of Peel Passive House Consulting had this to say during his energy modeling and certification AMA.
I think the key with the prefab is that you've got to design it right from the beginning with prefab and design around the prefab opportunities and constraints, right? In terms of standardized sizes or the jogs you have in the building, right? So it lends itself to a simpler building form, which also benefits in terms of making it easier to beat passive house. So I think it really needs to be integrated. Passive house needs to be integrated into the design as early as possible. And I think prefab really needs to be. So I think you need to make a decision for prefab early on and design around that. And actually, there's an initiative in BC, which we're potentially going to be collaborating with, that is developing a kind of standardized approach to prefab that's actually not relying on specific manufacturers. They're actually bringing a bunch of manufacturers together in a fashion to be able to support this initiative. Okay, well, how do we build particularly larger, like multifamily buildings in a standardized way? Repeatability is key.
It would be, because the tooling and that just the tooling for each individual property, of course, would drive up the cost. The standardization is the key. But is this initiative led by a particular company or consortium, or is it a kind of impromptu?
Yeah, this is at least supported by the government. It's called DASH. Many acronyms. I've forgotten the what it stands for. It's like digitally assisted standardized housing. I think it's something like that. But they're basically developing a kit of parts that you can draw from and design around, right? So it's like standardized sizes of components that you work with, almost like a catalog that you can say, okay, I'm going to use these to design. And so there is some flexibility with the design, but you're using repeatable components, including like interior walls and things, right? So there's still some need for architectural work and potential for some customization, but really key is just those standardized parts that you can use essentially.
And today's final clip is another great nugget from Lloyd Alter as part of his Sufficiency First Ask Me Anything.
We just have to look first at building nothing, next building less. Then if we have to do something, we'll build clever, and then we'll build efficiently. Will Arnold in the UK put it down to 3 words that have become my mantra, taking all of those, and it's just use less stuff. Kelly Alvarez Doran comes up with the same thing: less parking, less glass, less petrochemicals, less demolition, less floor area per person. Now, I look at Passive House, and I always have this problem with the original Passive House that, everything is measured in kilowatts per meter. So you can get giant passive houses and giant living building challenge houses, buildings like that, because it's all done per square meter. And it gets easier and easier the bigger the thing gets. And Nick Grant did this chart that shows you that the kilowatt hours per person just goes up directly in proportion to the floor area. And so there's got to be limits. Now, I learned after I first presented that FIAS actually does have limits, that they set their area on so many kilowatts per bedroom. They basically take the number of bedrooms plus 1 multiplied by their factor, and that's how they calculate the maximum amount of energy, which I think makes much more sense in this world than actually doing it per square meter. In Canada right now, there's been a history of doing small house plans, and the government just announced recently, before the election, they'd hired the best architects across the country to do small building plans. But they're all multifamily. There's not a single family house in the bunch. They're designed to go in as infill projects. They're all wood frame. They're all passive house. They all have no parking. And the plans are being produced and the zoning is being changed across the country so that you can take these plans and you can build them as of right. And this is the lowest carbon footprint of any kind of housing. Chris Magwood of RMI did the study and looked at the emissions per bedroom. And what you want to build are small duplexes and triplexes with a garden suite behind. And the worst thing that you can build is a single family house, 4 times the carbon per bedroom. I always end with this picture, which is of Stockholm in 1928, where you see trolleys and you see bicycles and you see pedestrians and you see a farmer's market in the background and slow buildings, which I always say could be Toronto or New York or anywhere in the United States or Canada if we wanted to do that now, if we thought about sufficiency. As Samuel Alexander said, this is a way of life based on modest material and energy needs, but rich in other dimensions, a life of frugal abundance, creating an economy based on sufficiency, knowing how much is enough to live well, and discovering that enough is plenty, which is how we have to think, I think, about designing everything.
Okay, wow. Thank you to Carmel, Graham, Silas, Lloyd, Sara, Bev, Rainger, Kristof, Alexander, Ilka, Greg, and Andrew for sharing their insights. As always, these clips just scratch the surface. So if anything piqued your interest here, please do dive into the full replays of these sessions available in the collective. And if you're not a member of Reimagine Buildings Collective, please join us. You'll get direct access to experts in residence as well as peers who are on the same journey. You'll get to know them, ask your burning questions, and expand your mind and your practice by engaging with these thought leaders and fellow trailblazers. Head over to reimaginebuildings.com to join. Speaking of joining the collective, a big welcome to our newest members: Sylvain Berriot, Mark Grimsrud, Diana Dina, Salen Black, Sky Ruozzi, Laura Carter, John Lorcher, Andrew Peel, Elliot Hedderly, Melissa Furukawa, and Jen Fagan. With that, thank you for listening to the 6th episode of the Reimagine Edit, a production of the Passive House podcast by Passive House Accelerator. As always, don't hesitate to DM me with anything Reimagine Buildings Collective related, what you'd like to see on the platform, any ideas you'd like to share. We're building this community with you, so let us know. And don't forget to invite your friends and colleagues to join us. Thanks, and have a great couple of weeks. Be well.